Hello and welcome to BroPartisan Hacks, where we discuss politics, culture, or whatever else we feel like. Hope you enjoy this short clip from the full episode. Alright, so I was talking about motors, and I mentioned that a motor, and this kind of works with any electrical device, but a motor is going to pull whatever it needs to turn, right? So if you've got energy going to a motor, and really any electric device like a microwave or whatever, right? It's just going to pull current. That's all it does. And so when it pulls the current, then it actually energizes and turns. If it can't turn, it's going to keep drawing more and more current to generate more and more torque. Okay, so if you don't have any limiters in the equation, which is the circuit breaker in this case, it's going to melt, right? It will pull so much current that it overheats and melts the wires. So, with that understanding, let's talk about kind of what happened this time, right? So, if we go back to the beginning, and I haven't, some of this is unconfirmed, some of this I've been able to piece together, some of this I know because I know how it works, right? And I kind of know how industry works. So if you have any questions, obviously just stop me and let me know.
Okay.
Right now, you've got both the green energy groups and the fossil fuel groups pointing the finger at each other because no one wants to take responsibility for everyone losing power. I think at the top count, it was like 4 million people was the number I saw of people who had lost power in their homes.
Yeah, that was at max. That was
the
peak.
max, right? So that's a lot. There's like 34 million people in the state of Texas. So 10%, 11% of everyone in the state just lost power. And some people lost it for days, right? So let's back up. So before the freeze happened, they kind of had an idea that it was going down. And ERCOT had requested approval from the Federal Department of Energy, to basically intervene on their behalf with the EPA and the TECQ, Texas Environmental Quality Commission, or Commission on Quality or something, whatever that, TCQ. It's basically the state regulatory agency that governs emissions and volatile organic chemicals, right? And on the 9th, I haven't been able to confirm this, but it's been reported that on the 9th, they had requested a leave to basically forego what their emissions limitations were with the upcoming freeze. Okay? So, hey, we got an emergency situation. We can generate a ton of power, but you got to let us, like, basically cut some corners here. It's kind of what that means, right? We can do all these things correctly, but with the reduced rates and with these low flows, it's not reduced rate. With normal rates, we can't increase to exceed our emissions allowance, basically from the state and from the federal government. So they asked for a waiver on the 9th for that, saying, hey, we need to generate more power. Okay? That didn't happen. They did not get that grant for the emergency purposes. So rolling around to Sunday, the officials kind of knew. Again, you can read this, and I've kind of pieced together a lot of this from a lot of different articles. The freeze started happening, and the temperatures started dropping. The first things to go were the wind turbines in Texas. It was the very first power drops. And going off of the ERCOT numbers, so their winter... So there's two different things that happen with wind turbines, right? You have what they're rated for, and then you have what they actually produce. Mm-hmm. The ratings, that like the sticker ratings on these all the wind turbines in Texas is somewhere in the neighborhood. I've gotten conflicting numbers based on different things. The numbers that I saw in ERCOT for what they're actually rated for is about 32 gigawatts or 32,000 megawatts. Which is a lot of energy, right? Like Texas has the most wind energy of any state, period.
Yeah.
because we got West Texas, right? I mean, you just plunk a wind turbine down there.
Tons of wind farms out there. Yeah.
So the first thing to go were the wind turbines, but they only lost about 6 gigawatts, right? Because that's about all they were generating at the time. So they could put up like 32. Really, it's more like 6 or 12, right? But anyway, so the first thing to shut down was the wind turbines, and that was Sunday night into Monday, right? So they froze first. And we talk about loading, right? And we mentioned how circuit breakers can trip. If you've got too much power going to one circuit, it'll trip that breaker. So what happened when the wind turbines went down is that you had all this power coming in from West Texas, right? And the wind farms out there. And then all of a sudden you didn't, right? Because 6 gigawatts is still quite a lot of power. At the time, it was about 4 to 6% of what they were putting out for the state at the time, okay? But a 6% drop immediately, essentially, is a huge number for everything else to kind of compensate for. So the grid is all interconnected, and everything else kind of ties in together within the state of Texas and the ERCOT region. And so you had a shutoff in one area, and these other plants had to pick it up. So what happens to the switching stations that are kind of in the middle, right? Now, instead of having a balanced load coming in from one side, going the other, and going this way, you've got all your power coming in one direction and trying to feed out multiple points.
Okay.
And they just simply overloaded. And so the first thing to go down, again, the wind turbines, then the switching stations that those were connected to, that were actually the distribution points to about, I want to say like a few 100,000 people were affected with the first blackouts. Now, the gas turbine makes up about 53% of the energy production in the state. They're super efficient. Gas was really, really cheap recently with the fracking, so a lot of people built gas turbines. And the gas turbine outputs that I've seen, they had increased output, in some cases up to like 450% output. So these things were running basically as harder than they ever were designed to, in a lot of cases. A lot of the coal production facilities I saw had increased power output by 100%, so they're now running at 200% capacity. And that was because on Sunday night, the EPA and the Department of Energy finally came to an agreement that they could bypass the emission standards. They say, hey, this is emergency purposes. You guys put out the power. Get it done. And so they did. And then all of these wellheads, you see in the news about the wellheads. So wellheads in Texas are basically just like holes in the ground. That's really it, and the wells are typically just an underground cavern. And the way that you get gas out of these, in a lot of cases, you can use two different mechanisms. One is to fill the wellhead with nitrogen. And so you pump nitrogen. So there's a cavern underground that's full of gas, right? This is your fuel source. It's like a big fuel tank for the plants. And what they'll do is they'll pump nitrogen into the ground underneath it to pressure it up and they'll have the tube basically down at the bottom of the well. And it'll push the gas, of whatever natural gas you have in there, out of the wellhead with the nitrogen pressure coming out, right? You push something in, the gas comes out. And sometime around, I think Monday at 2 a.m., the water started freezing. And we started losing major distribution hubs. I know that I got a letter from my city saying that within 30 minutes they had dumped 100,000 gallons. They just lost it, right? It just poured out wherever it is, So the whole system drained across the state because none of this stuff is winterized, right?
Right. No.
For the major distribution centers, like we live in Texas, it doesn't get
Why would it be? And that's one of the things, like, yeah, I've always, like, through this whole thing, I understand why you wouldn't do it.
Yeah.
It's a huge cost. Like I said, it's for wind farms, it's $150,000 per unit.
That's just for the equipment. That's not to pay the people to go out there and install it. That's not to get the rig, that the massive rig that you got to get it out there to install it on the wind vanes. So like that just barely scratches the surface. So really the cost to install one of those things is probably closer to the neighborhood of like $500,000 or $600,000 just for the people and the equipment you need
unit.
To do one unit.
And there's hundreds, if not
and there's
thousands.
There's thousands of those things.
No, I mean, I get it. I get it. That's all I'm saying. I understand why they didn't.
The cost to retrofit is astronomical. Now, if you were to like build new, it's a shot in the dark, right? It might cost you $1 million, $2 million to build this wind turbine, right? I don't know how much they cost. I'm just shooting in the dark. I know how much materials cost. It might cost you $1 million to build a wind turbine, right? And so if you tack on $150,000 to the price tag of that to winterize it when it's in construction, super easy.
Yeah.
But now you're paying 50% extra cost on something that's already in service, that's already out in the field. You got to get the equipment there, and these things are in the middle of the field in Texas, and that is not easy terrain. Like over in West Texas, that's desert, rocky, terrible. It's not good, man.
Yeah.
So wind turbines shut down. Water started freezing. So water that's moving doesn't really freeze, right? If you can keep it running water. You might, like at a surface of a creek, you might keep the top layer might freeze, but the water underneath keeps running, you know?
Yeah.
So a lot of these municipality districts have like what's called dead legs. And it's basically just a point in the pipe where you'll have like an old T in the pipe. And instead of like rounding that elbow off, they'll cut the pipe off and just weld the plate on the end of it. And so you have static water that would sit in that location. So that happens sometimes, and I would hazard a bet, because that happens so frequently, that's where the break started, right? So anyway, so the water pipes burst, right? So what happens when water pipes burst? Well, if the whole distribution network goes down, which is what happened in most major cities across the state, and rural cities, really. Everybody kind of lost water for a little bit, which was very, very dangerous, right? You can only live a few days without it. So what happens when the water goes down? Well, if you don't have a source of fresh water and just replenishing condensate water system, you can't really run a steam turbine, right? So... So when the water pipes froze, a lot of these plants just had to shut down, because if I don't have water, I can't make steam. And if I can't make steam, I can't turn the turbine, right? And it doesn't matter what your fuel source is at that point, whether you're nuclear or gas or coal. It doesn't matter. If you can't get water to make steam, you can't make power. And then the nitrogen plants shut down. Now, nitrogen is important for more like the chemical industry than the power industry, but the power industry also uses it, and they use it for like as basically the inert gas to move the fuel cells, move the fuel around, like I talked about with the wells. They use it to clear the equipment whenever you go to work on it. They'll use nitrogen to sweep and purge all the chemicals out of it, whatever they're, if they're pumping oil or whatever else, they'll sweep it with nitrogen to try and dry it out as much as possible before someone goes and actually works on it. They also have to do that when they're putting it back together and they're recommissioning it. They have to sweep it with nitrogen to get all the moisture out of a turbine before you can start it up. So if you don't have any nitrogen, you can't even start your turbine back up, even if you need it and you have the supply and the water and everything else. So all these things are like interconnected throughout the state. So nominal production of the state is about 81 gigawatts or 81,000 megawatts. You'll see it in news both ways, both gigawatts and megawatts. So 81 gigawatts is like a billion watts, right? That's a lot.
I mean, it's not close to. I mean, it's a little bit more than 1.21 gigawatts.
Gigawatts, yeah. I think that's a real thing.
1.21 gigawatts.
You could say, I guess you could say it with a hard G instead of a soft G, or a soft G instead of a hard G.
I'm just old, and so
Yeah, you want to time travel? Go back and tell him not to mess this up.
My knowledge of gigawatts stems from the flux capacitor.
Back to the Future. Yeah. Oh, I know.
The flux capacitor of the DeLorean. You gotta get the lightning strike to get 1.21 gigawatts.
Yeah, so I have here like coal capacity output increased by 100%, gas turbine capacity increased by 450%. And again, that was at the height of the power losses. So when half of the production facilities that were operational went down, and these gas turbines are now running at 450%. So they really, like, in all reality, it could have been so bad that instead of like 4 million people losing power, we could have had like 15, 20, 30 million people without power. Right?
Yeah.
So that's just kind of like a thing of like how much can you backfill the supply, because everyone's still demanding, right? Your motor is still locked up, everyone's house's lights are still on, they're still trying to draw power, right? And that's where it comes into like load balancing. When you hear the news talk about load balancing, what it is it's trying to match supply with the demand, right? So basically, if you want to get down to like, now ERCOT's going to do their investigation, right? They're going to have a federal investigation probably. There's probably going to be a few commissions in the state of Texas that the state legislature are going to come up with to do investigations on all of this, right? So everyone's going to be doing their investigation as to like what happened, what went wrong, what could have been done better. If you look in the news article, you would see that like Greg Abbott was railing against the ERCOT executive, whatever the managing director is, of ERCOT. So the long and the short of it is that, in my opinion, again, and I'm just someone familiar with the industry. I know enough about electricity to get myself in trouble with the electricians. I'm much more of a mechanical guy, mechanical engineer. In my particular degree program, I did a lot of electrical power and a lot more electrical analysis than like your standard mechanical engineer that would graduate with an ME. When I run into issues at work, I still do have to go and consult the experts, but a lot of times I can figure it out, right? So that's just kind of where I'm at. Anyone who's telling you that like, oh, it's all wind turbines' fault, or it's all fossil fuels' fault, the answer is they both screwed up.
Right. Well, it was just a complete system failure.
Well, it was a complete system failure, but at the end of the day, the only reason that anyone had any power, at least in the state of Texas, was because of fossil fuels. Because the wind turbines shut down first, and they did not come back up online until I think the earliest one defrosted Wednesday afternoon.
But even then, you really can't blame them because they didn't spend the money. Like I said, a choice was made.
A choice was made, absolutely.
They absolutely, that was...
Go ahead.
Absolutely was preventable. Like, there's no way that, like, those things still function if you winterize them. So there's a money sense there that
so do coal plants and gas plants, though. the argument cannot be made by saying like, oh, the turbines can run if you winterize them, and then not recognize the same is true for every other power plant. The fact of the matter is that in Texas, we didn't winterize anything, right?
Yes, I agree.
You're talking about winterization as a direct means to prevent these things. Now we're going to talk about that. That takes me into very nicely segue into credible scenario.
Thank you for watching this episode of Bro Partisan Hacks with Reese and Rob. We really appreciate you watching, tuning in. If you like this video, please hit the like button. Please subscribe to us. We're putting out content as often as we can. Share it with your friends. Get it out there. Get our names out there. Also, hit that bell, tap that bell right there so that you can get updated when we put out a new video. Rob and I are trying to pump these videos out as often as we can. However, we both have day jobs, we have families, so our schedules have to line up so that we can make a new video. Speaking of our day jobs, our opinions and views expressed are our own and in no way represent those of our respective employers. Thank you. Thanks again for watching.